Good afternoon, everyone, and welcome to today's webinar with Qlucore. My name is Mats Svensson, and I work here at Qlucore with support, customer issues, and development. And I'm here today to present to you our new and exciting version 3.5, which contains quite a few new items for you to use in the software. So this webinar is a general webinar about 3.5. We will have continuing webinars in the future here with in-depth focus and a little bit longer than this one on the various aspects of 3.5. So today I'm just going to give like a brief overview of what's available, what kind of new features are available in the software today. So that's what I'm going to do today. And as I said, in-depth webinars will be held during January and February here in Qlucore webinars. So that's what's going to happen. If we take a look at the overview of what we've done in 3.5, is that our main feature, the parade feature for 3.5, is something we call templates. And to briefly explain what templates is that it's a way to configure workflows or a way to script the program. You can develop your own workflows, your own ways of working to set up the program and develop those yourself and use them within your organization. And typically a template is a computer program written in Python that controls Omics Explorer, and that program can do almost anything that the program can do. So what you can do is you can set up, for example, standard plots or standard ways of setting up the statistics in order to guide your users into a pre-configured workflow. That's only one of the aspects, though, because a template is a Python program, which means you got all the power of the Python language available to you, which means you can do almost anything. I'll show you a little bit about this today, and there's going to be, as I said before, extra webinars about this, a focus on this entirely. Also, we have added much more rich plot options, so you can configure your 2D plots a lot more. That's quite a big addition to the software as well. We have two new plots, Talus and Scree. The Scree plot is well known since before. However, the Talus plot is something new that we have developed. I'll just show them briefly today. There will be a lot more about this in later webinars. We have also upgraded the Qlucore unique feature projection score, which we call projection score generation 2. Projection score is a tool to help you find the optimal variance filtering for your data set given the parameters you have at the moment. And what we've added now is also an automatic configuration feature for this to help you get the optimal projection score immediately. I'll show that too today. We also added, which I'll just briefly mention today, 2 key statistics. We have those in the box plot. We also have the ability to export this with the variable list export. And the last but not least thing we've done, or sorry, one of the last things we've done is that we've upgraded the NGS module for those of you who use that, which is an add-on to the regular Omics Explorer, where we can show HGVS descriptions of the amino acid changes that are caused by variants in the genome. The last thing that we have added in 3.5, you see there's plenty of small things and a couple of larger things. This is the last of the small things. It's filtering on difference. And filtering on difference works in the same way as filtering on fold change, although fold change is 2 to the power of the difference, whereas difference is the logarithm of the fold change. So you can select on which of these to filter now. So we've changed the filtering of the fold change filtering part of the statistics dialog a bit. So all of these things have gone into 3.5, and the first thing I'm going to talk about is templates, which is the largest addition. It's maybe the largest addition we've done to the program since we added NGS to the software. And this is really exciting because what we're doing here is that we're opening up the program so you can write your own scripts to control the program. which means that I have no idea what people will do out there with this and what you'll build with this. This is a toolbox which is richer than maybe anything we've released so far. And just to sketch an idea what you could do with it, you could invent lots of more things to do with this, but you could, for example, set up a template to run the same analysis many times. So all the steps needed to do the analysis, to set up the statistics correctly, bring up the right plots, configure those plots, and generating reports or exports. You could set that up as a script, and then you could run that same script for many different data sets, for example, instead of having to do that manually. It will save you time. It will also make your analysis better, because this removes parts of the human factor from the loop, as the steps will be perfectly repeatable. Another thing you could do with this, of course, is to integrate Omics Explorer in existing workflows and expand them. And what do I mean with that? Well, let's say that you have some data in a format that we don't support at the moment. Although we support many forms of data, and we also support actually kind of a wizard import of data, where you can import your data by telling Omics Explorer about your data. You might have like a data format that we don't support at the moment, but it could be convertible to something that we would understand. With Omics Explorer, you could write your own Python program to like interpret this data and output it in a format that our software can read. You could also have Omics Explorer run and trigger external events, like starting up an external tool and doing parts of the analysis outside Omics Explorer, and then bring the data back in by reading data into Omics Explorer. And here, configure your favorite analysis for a quick start. One thing I use templates for at the moment is that I often bring up like a few standard plots. I bring up a heat map, maybe 2 PCA plots, and a few other things. I've written templates to do that for me. So what I can do is that I can take my data set, load it, and then I can just call that template, and boom, I have all the right plots on the screen instead of having to open them manually. Saves me time. It also makes things repeatable for me. And for new users of the software, this is a way to get started, because we bring in a couple of pre-configured templates, a few of them, like 6 or 7 in the current release, to show important concepts in the program. And these can be viewed as mini tutorials or ways of getting started to know the program, what it can do. And we are going to expand the set of example templates that are shipped with Omics Explorer in the near future. So in the upcoming service releases for 3.5, there will be lots of exciting new little templates that you can play around with and learn the program. And for those of you who are more experienced users, you can take those templates and take them apart, because they contain scripts. I'll talk about that in a moment. And what you can do is you can take them apart, look at those scripts, and use them as inspiration when you're building your own templates. So we're giving you a big toolbox to play with here, and a big toolbox to build things with. So hopefully this is going to be very useful to you guys out there. A little bit more details about this then. As I said, these are Python scripts. Templates are written in the Python language, and that was chosen because Python is a very modern, very well-established language today. It's modern and object-oriented. It's easy to learn, and it's also widely spread out there. And it's a very good language for this type of program control, or this type of like scripting something. So Python is an excellent language for this. It's easy to learn for those of you who don't know it, if you want to write your own templates. Also, there's plenty of literature out there. There's plenty of help on the internet to get to learn Python. So I believe it's a good choice for language for this kind of application. Now, when the template executes, it actually executes in Python and sends commands to Omics Explorer, and Omics Explorer parses those commands and does things to your running instance of the program. We do ship the program with a full installation of Python, and we also ship the program completely out of the box, ready to run these templates. So there's nothing you really have to configure yourself, although you can if you want to, because if you want to have your own Python installation, that's perfectly possible. And basically anyone can write new templates. I won't go into detail on writing templates today. That's something I'll save for the webinar on that. However, I would argue that anyone with basic programming skills can learn to do this. Another cool thing with templates here is that templates are not just a script file. They're actually a little container, because a template is really a zip file which can contain other files. So the template can contain other resources as well. For example, if you have a data set that you want to ship to your colleagues and ship that as a template, you can do that, because you could put the script and the data set together in that zip file, and you could configure the script to bring up a series of plots and set up the program in a nice state to show what you want to show your colleagues, for example. So it's a way of communicating things as well, or could be, potentially. The last thing I want to tell you about templates, we'll have a look at running these later on, is to tell you that they could have a user interface, which means that the template can ask the user for input. You can get input from the user to control the template. There's also ways of getting input from the user so you can control the flow of the template. For example, you could have a yes/no question and have buttons on the screen where the user can answer a question, and the template could go different paths depending on what the user has said. I'll show you a few examples of this later on as well. So that's the biggest feature we've added this time. But there's plenty more in this release, and there's a few things I want to highlight before I show you the demonstration today. And one of them is the rich plot options, because one piece of feedback that we've gotten from several customers is we often get these questions from customers because you have regulations from your publications that a plot is supposed to look in a certain way or use a certain font and so on. Previously, there has been less configurability on our plots. What we've done in this release that we've added quite a bit of new options to let you control the font, for example, or control how a plot is rendered on the screen and in the export. You can get more things on the axis, for example, PCA components in the scatter plots. You can connect the samples in a scatter plot, but we also have added things like fine control over the tick marks in axis on the plots, because that's typically something that we get as feedback from people who want to publish these things in publications. We also allow different symbols for values, which can be really useful because you might want to show different aspects in the same plot, and by using different symbols and populating the plot with different symbols gives another dimension of information to the plots. And as I said, much more flexibility is added now with different fonts, different sizes, settings for different objects in the plot. You can configure these things a lot more, and expect this to grow because this is a field in which we will focus quite a bit in the near future. Now we get to the mathematics side of things here, because this is something we've done on the more theoretical or mathematical side of Omics Explorer for this release here. The scree plot is described in literature since a long time back. The talus plot is a variation of that. And basically what a scree plot shows you is that it shows you how much of the variance is captured in each principal component when you do principal component analysis. And this is a way of estimating how complex is my data set, how much information is carried in the lower dimensions and how much is carried in the higher dimensions. This also gives me an idea of the degrees of the number of degrees of freedom in a data set, because if I'm doing, for example, a controlled test where I have like a control group and an experiment group, I expect like very few degrees of freedom because I want to have control over this experiment, obviously. And if I then take up the scree plot, I expect to see a very steep scree plot, which means that I basically have few degrees of freedom. If I don't have that, and I have done a controlled experiment, I've got lots of really significant error sources, and I might have to go back and redesign the experiment. So this is a good way of validating that you have actually done your homework when it comes to controlled tests, for example. And I should say the talus plot is a talus plot, so is a scree plot with a transformed scale, which amplifies the local variations, which means that it's easier to see what is going on in the higher dimensions, because usually in a scree plot those things are scaled so small it's very hard to see what is going on. I'll show this briefly when we're looking at the program to give you an idea of what I'm talking about here. Next mathematical update is we've done updates to the projection score, which is the projection score is an invention by Qlucore that we have had in the program since a couple of years back. And the projection score is a tool, it's a rule of thumb or a way of guiding you to finding the optimal variance filtering when you're doing PCA analysis. And it will the optimal projection score will give you the optimal projection or the optimal variance filtering setting given that data set. So previously we've just displayed the projection score up here. What we're doing now is that we're displaying the projection score, but we're also providing this optimization button, which will allow you to immediately move the variance slider to the optimal point. This is really neat because it saves you a little bit of work moving this thing around, especially when you got lots of samples and it takes a little bit of time for your computer to update those. This can be a real time saver to do the optimization this way. I'll show that later on as well. And here's another thing we've done. I'll just mention it. I won't show it today. This will be in later webinars. When we're doing box plots, we also have added legends up here for Tukey and fold change, so you can actually see Tukey's range. You can see the Tukey's range test probabilities and p-values here. You can also have the fold change plotted here. And for Tukey, since this is a combinatorial way of showing things, we allow up to 4 groups here. The reason for that is that the number of combinations will explode beyond 4. So it will be a very messy plot if you do more than 4 groups. So we're limiting this to 4 groups at the moment. The Tukey levels, the Tukey p-values can also be exported when you are doing variable list exports. I should say that as well. We've done a few service upgrades to the NGS module. We had some feedbacks from some customers that are using this, and they really wanted genome level HGVS descriptions. And what this means is that we should have standardized, for those of you who are not into NGS, this means that we have a standardized way of showing mutations that is following the HGVS standard. And what we're also doing is that we're showing this on the protein coding region, which means that we can actually see what a mutation will result in terms of changes to the produced amino acid or the produced protein. So there's information added in the tracks, in the report, and in the info field. I won't be showing this today because not everyone here is into NGS, and there will be NGS webinars during the early spring to show these added features of the NGS module. So I won't show this today at all. I'm just mentioning it. We've changed the statistics window. Those of you who have used the software a bit, you'll have to get used to slightly different statistics window now. What we've done is that we've moved the variance filtering to its own tab. This is due to the new features with optimization and so on, and we also believe that the statistics is a cleaner interface to the user if we have all the statistics on one place and all the variance filtering in one place. We've also changed this thing here on the statistics tab. We've added a new drop-down box here where you can change whether you want to do fold change or difference filtering. When you're doing a t-test, you can filter by fold change. We've had that in the software for a few years. What we've now added is you can filter on the difference instead as well. The difference would be the logarithm of the fold change, of course. The 2 logarithm of the fold change. So 3 tabs instead of 2, and support for this is what we've added in this window. That was what I wanted to say about the software in the presentation. Now I'm going to give you a brief walkthrough of a couple of the new features that we've added in 3.5. So let's bring up Qlucore Omics Explorer on the screen and take a look at what's going on here. I'm starting by loading an example data set because I'm going to use this example data set to illustrate what the templates can do. I'll just change the proportions of my windows here a bit. There we go. And what I'm going to do now is that I'm going to run a template. And a template can do things to a data set. It could also load a data set and independently process that. But in this case, we're going to work on an existing data set. So to start my template, I bring up the template browser, which is reachable from here in the file menu. It's also reachable from here with a quick launch button here. I'll launch it from here for now. And when I bring up the template browser, I get it here on the screen. The template browser will search designated locations, which you can set for templates. And right now it's pointing to the examples directory for Qlucore Omics Explorer. So here I'll get the list of the available templates. And if I click on one of them, it will bring up the templates user interface here, which can contain pictures, text, and in some cases, I'll show a different one here. It can contain widgets or controls for which you can control it. And of course, there's a description text here as well to show you what it's going to do. And to start with, I'm going to run a simple template. The first one we looked at here, 3 plots. This is just a demonstration example of what a template could do in terms of bringing up plots, because I've got a data set open here. Actually, this template requires the data set to be open because it operates on it. If I close the data set here, you see the text goes away here because it needs to have a data set open. So I'll have that data set open here for now. And the only thing this template does is really it brings up it takes my plot and creates 2 copies of it and configures them for me. And it's going to bring me 1 PCA sample plot, 1 PCA variable plot, and 1 heat map. So if I press execute here for the template, that's exactly what it's doing for me. It sets the software up for me. So these commands that created these plots are written as a Python script that were executed by Qlucore Omics Explorer. So that's all good. I'm going to show you a little bit more interesting template that does a little bit more now. And this second template here that I'm going to show you performs a t-test with fold change. And there's some explanatory imagery here. There's some text. What this really does is it performs a t-test for me. So I select an annotation here. Treatment is good. I'll choose one of the drugs here. Let's change the direction of the test. What Q value cutoff do you want? Well, I want a Q value cutoff of maybe 0.1. And a value for fold change cutoff, let's say 1.6. There we go. Now when this template executes, it will do a lot of steps. It will bring up different plots. It will bring up the statistics window. It will configure the statistics window with these settings for me as part of the execution here. So there we go. The test is performed. And the statistics window was brought up. However, I think it ended up on my other screen here. Or maybe it... Let's see where it is. Yeah, it's here on my other screen somewhere. Let me see. There we go. It was located on my other screen. I think. Wait a second. I have so many windows. Here it is. It's behind a lot of other windows that place themselves on top of it. So the statistics window was brought up as well, but ended up on my different screen here. So these steps to configure these plots, set up the statistics and so on, was done automatically by the template. And if we bring back the template browser here, all of this was controlled by the widgets that are in the template here. So you can have a user interface on the template, use that to bring information to the executing Python code. All right, that's what I'm going to say about templates for today. And as I said, somewhere in January, there is going to be a webinar that focuses on templates that will bring up details about this and which will show a little bit about how to write them yourself as well. I'll show a few other things here as well. I'm going to show the scree and the talus plots. And let's remove this variable list, which is not needed anymore. There we go. So if I bring up this data set and make, so these are two synchronized plots now. If I want to know something about the dimensionality of this data set, how many dimensions or how many degrees of freedom there are in it, I could bring up the scree plot. The scree plot tells me how much information is in each principal component. If you look at the three first principal components here, 21% of the variance is captured by this dimension here. That's exactly the value you see here on the scree plot, because here 21, that's the first dimension. The second dimension is 7. You see 7 here. And the third dimension is 3%. There you go. Sorry, 5%, which is here. So the scree plot shows you how much is captured by the dimensions here. And this also shows me that since I have a very steep curve here, most of the information is captured in the lower dimensions, telling me I have quite few degrees of freedom here. If this had been less steep here, I would know that there would be more information to the right here. But the problem with this kind of plot is that variations in the higher dimensions are very hard to see, because as you see here along this line, it gets smoother and smoother, but it really is not the truth, because there's quite some variation between these higher dimensions. And that's exactly what if I bring up a third plot here, that's exactly what the talus plot is designed to solve, because the talus plot shows the logarithmized difference between each dimension rather than the dimensions themselves, which will give us a different view. And as you see, this is much more jagged because it amplifies the differences, which lets us see better detail in the higher dimensions. That's a little bit about some of the new plots. And while we're at it here, these are 2D plots. And what we've also added here is the ability to select the axis and bring up the settings here. Or you're supposed to be. Sorry about that, because that also ended up on my other screen. Wasn't very good. So if I double click on an axis here, for example, I can directly go in and change the font here. So if I want to change the font, this is silly, of course. I'm changing the font to symbol. But just to show you that it's possible to change the font to whatever you like here. So there's a lot more you can change. You can change the tick marks by clicking those and directly access the axis settings and so on. Everything is a lot more configurable than it was previously. So that's template execution. That's variable. That's template execution. That's the talus and scree plots. I'll show you one more thing while we're at it, since we have a PCA plot here. We have a PCA plot here, and if we bring up the statistics doc window again, as I said, this has been changed now, so you have fold change and difference filtering. You can choose between these two. Right now it's switched off because you need to have a t-test for these to be active. I can show you that. So if I do a t-test here, a leukemia subtype, for example, like this, I could filter by fold change, like this, or I could filter by difference, which is the logarithm of the fold change. It's the same filtering, but it's just a different scale, basically. They're both useful. It depends on what you're looking at, really, which is more applicable to you or what you're used to using, really. But it's the same thing you're doing. But what I wanted to show you here, which is a bit more interesting, is the new projection score, the projection score generation 2. We've had this for quite a while. The projection score is shown here, and as I move the variance slider, the projection score eventually changes, as you see here. It goes down and then it goes up again. So what we have here is like a value of 0.41. It goes down and then it goes up again, and it reaches a maximum around here, and then it goes down again. And the projection score is an estimate of the quality, or where is the best, from a dimensionality perspective, way of filtering variance to capture as much information as possible in the plot. And you could find an optimum or a nice way to filter your data set by moving this thing around and experimenting until you get something that fits, which is not very much a scientific way of doing it. That's usually one thing that can be criticized with many studies, because people do variance filtering on a plot like this, and they find what they think is a good value, and we filter by this variance. Yeah, but why? You don't explain why. Projection score is a way. There are references in our manual to have a good way of doing this and have a reference on why you did it. And instead of moving this thing around and trying to find that maximum yourself, which is kind of there somewhere, you could tell the software to optimize for you automatically. So I can just press opt here, and I'll get the optimal value for the fold change. But remember, this is just a rule of thumb. But it will give you a good value. And in this case, it gives us a good value because what I got here is a leukemia data set. And acute lymphoblastic leukemia has two main types. There's one of them. There's the other one of them. It's very obvious. And this second type has very many subtypes, and it even is distinguishable from this plot here, that we can see at least one of the subtypes here very clearly, and possibly another one here. So that's what I had time to show you today. I'm already a couple of minutes over time. Questions about this that I've shown you today? If you want to ask me a question, feel free to ask me that in the chat window. Type it to me, because it's very difficult for me to hear when I bring up the audio from lots of participants. So if you have a question, type it to me. And if you come up with a question afterwards, after the webinar is over, feel free to contact us at Qlucore at the support email, support@qlucore.com. I'll type that in the chat window. That's the email address to mail to if you got questions after the webinar. If you are already customers, some of you are doing evaluations right now. Feel free to contact us if you want to have help getting started with these new things, or if you get stuck when you try to use these new features or anything. We're here to help you. So anyone with a question? Is it perfectly clear to everyone? Well, apparently so. So I hope this gave you a good overview of what's new in this version since the last one, since our last release this spring. We've come up with these new features. So stay tuned for other webinars with more details. And as I said, there's already one planned in January now for, oh, let's see here. Oh, someone asked me a question here. Sorry. Let's see here. The question is, what is the number 3 in the dimension referred to, oh, right, this one here. That's a good question. I didn't bring that up. There's a lot more detail about this in the reference manual, but I'll tell you about this. This here is by default 3. I can add more if I want to, because the projection score is calculated on a number of dimensions. In this case, 3 dimensions. If I want the projection score calculated for just 2 dimensions, I can let it do that, which means it will disregard any dimension beyond the second one. It will just use actually this one, 21, and this one, 7%, to calculate the projection score now, which means it will disregard this dimension and all the others when it calculates how good the projection is. In this case, I end up with a much worse result because I didn't take all of the information into account. It's not much worse, but it is worse. Although I have actually 21% of the variance captured in one dimension. So if I do optimization here you see I get a much worse result because I didn't take at least one other dimension into account. However, if I know that my data set has lots of degrees of freedom, say that I know that I have like 5, 6, 7 degrees of freedom in my data set, I could actually force the projection score calculation to take more dimensions than 3 into account when it optimizes this. And I could try to see if I get a better result. In this case, I do get a good enough result with 3, so it's hard to see any difference between 3 and 6 dimensions here used for this. Other data sets with much more complex relationships between data, you would end up with possibly better results by doing this. So that's what the number 3 refers to. I hope that answered your question. Anything else? Okay, as I said, in January there's going to be a bigger webinar. It's going to be 1 hour long on templates, which will show a lot more about the details of templates. It will go into more detail on how to write your own templates. It will go into more detail on how to use templates to leverage your work and create these repeatable workflows that I was talking about. And we'll do a lot of cool things during that webinar, so I hope that you'll join for that. Let's see, I got a second question here from someone else here. How can we generate box plots on all the variables? Okay, that's a little bit out of the topic here, but I'll try to show you anyway. So you're talking about how to generate box plots for all the variables. Let me see what I think you mean here. So if I have my data set here, I'll choose box plot here, and the data selection here. First of all, I need some annotation for the x-axis. I choose the leukemia subtype here for now, and here I can select manually the variables. I could click on this one. Now this won't work because I have too many variables. I have 600 variables. But if I click on this one here, I get a box plot for all the variables. We do have a limitation, however. We have a limitation to show a maximum 64 plots, because if you get more than 64 box plots, they will be very, very small, and it will be a very messy picture on the screen. So if I take my data set here, let me bring up the stats window again and do some variance filtering so I get very much fewer variables. There we go. Now I'm down to 8 variables, and there's 8 box plots. So all of my variables are shown now because I have fewer than 64. So yeah, you can generate box plots for all variables, but we are limited to maximum 64 at a time, because otherwise these plots will be too small on the screen. The next question I get here is, we cannot generate only one box plot for all 610 variables based on leukemia subtypes. No, because each of these plots is for a variable, and the y-axis is the variable, the x-axis is the selected sample annotation, in this case leukemia subtype. That would be 610 plots. That's my basic answer there. Let me see here. How can we average the variables? There are ways of averaging variables available. However, if I understand your question correctly, how can we average the variables? Well, if you want to average your variables, you must ask yourself, what are you averaging on? There is one way of averaging variables available. If we go to let's see here, the data tab here. If we go to take the gene symbol here, for example, we have this feature which has been available for a couple of years called collapse, which will do averaging. So if I do collapse here, I have only 5 variables left. The reason for that is that what I'm doing here is something we call a collapse operation, which takes all variables which have the same gene symbol and creates one compound variable out of them. And you have several different methods of doing that. Right now I did averaging, which was what you asked for. You could do it with median. You could use the maximum or the minimum value. And I can remove the collapse again by pressing none here, which brings me back to this view. So that's one way of averaging variables. But when you're averaging variables and reducing the amount of variables, you have to ask yourself, what are you averaging for? What are you averaging on? And in my case here, I was averaging on the gene symbol. Right, I got another question here. See here, how useful is it to elaborate a t-SNE graphic, and how can I elaborate it? Is there any new thing for that? I don't know exactly what you mean with elaborate, but when it comes to the t-SNE functionality, that's something that we added in the last release, 3.4, this spring. The t-SNE is a variant on the scatter plot, which is available here. So if I bring that up, I can bring up the 2D t-SNE here. By the way, I should show you this as well. Here's a new way of, since some of the plots are hidden behind a type here, you have only a limited amount of buttons here. You can bring up all the available plots by pressing the all button here. And this even is expanded, so you have the PCA sample, PCA variable, and so on here. So we're at the 2D t-SNE plot here, and a t-SNE plot can be calculated. This is a statistical algorithm. I'm not very good at t-SNE myself, so I can't really answer your question really very much. But t-SNE is an algorithm which helps you find clusters of samples. If I color these samples by the actual diagnosis given by the doctor here, we see that in certain cases it does quite a good job. In other cases, not. But this is not really fair, because I wasn't at the beginning of my analysis here. I brought the variance back to let's see here. If I use a dimensionality of 3 and I filter by a little bit of variance here, and I try to calculate the t-SNE, here I got a better picture. As you can see here, the white samples are pretty much grouped. The purple samples are pretty neatly grouped. These brown and red samples are pretty neatly grouped, and the blue ones are really well grouped. This is another way of visualizing samples. I don't know enough details of the t-SNE algorithm myself, I should say, so I can't answer your question more than that. I can just show this thing to you. There are other people here at Qlucore who know this much better. So if you want to know more about t-SNE, please send a question to the support email. I will forward that to one of our mathematicians who knows this algorithm much better than I do. Okay, good. Plenty of questions today. That's fun. So people are starting to drop off here today. And as I said to the participant who asked that question about t-SNE, please mail that question to us, and I will forward your question directly to the person who knows this best. Right, it's been fun to show you this thing today. It's been fun to have so many participants, and I wish you all happy holidays, Merry Christmas, and a good New Year, and a Happy New Year, and have a good day until we see each other again. And I hope that you'll come back for the templates webinar in January, because that's going to be a lot of fun things to see. So thank you very much for today, and bye for now.